Hey guys, welcome back. This problem is problem 18 on both the AMC 10 and the AMC 12, 2022, 10A and 12A. This problem is actually not that hard once you understand what it's asking. The hardest part about this problem is understanding what exactly it's asking. I at first did not understand this question, and I still think that it's not worded great. I think there could have been a more clarifying wording to this problem that would have made it make a lot more sense. Okay, so let's read it. Let t sub k be the transformation of the coordinate plane such that first rotates the plane k degrees counterclockwise around the origin and then reflects the plane across the y-axis. What is the least positive integer n such that performing the sequence of transformations t1, t2, t3, tn returns the point 1, 0 back to itself? Well, okay, the part that I didn't understand about this question was when they say rotating the plane, I assumed that meant rotating the coordinate plane. But you're not really rotating the coordinate plane, you're only rotating the plane that the point is on. So the coordinate axes are remaining where they are, you're just rotating the plane that has the point 1, 0. Right? And you're just trying to find how many of this repetition until you get it back to where it started. So you kind of just have to sort of get an idea of what's going on here. So if you start by sort of making an x and y axis, right? And you sort of imagine it's going to rotate 1 degree counterclockwise, but then I'm going to reflect it. So it's actually going to be over here. And it's going to be like that, right? So it's going to be like somewhere over here. So it's 1 degree clockwise from the left x-axis, right? So 1 degree. So we'll just say 1 degree clockwise, right? Now, what will happen next? Well, that point will get rotated to, so now it's actually 1 degree clockwise. So it goes 1 degree 1 degree clockwise and then 1 degree, no, 1 degree. Oh, okay. So maybe I shouldn't say clockwise. 1 degree up from the left x-axis and then 1 degree down from the right x-axis. Right. And then you'll do this again. So now from that point, it's going to go 3 this way, which means it's actually going to be 2 up and then gets reflected. So now it's 2 up from the right x-axis, left x-axis. And this way, so now it's 2 down, so we reflect that it's 2 down from the right x-axis. And then if you just you're just going to start seeing a pattern. It's 1 up, 1 down, 2 up, 2 down, 3 up, 3 down, blah, blah, blah. This pattern is just going to continue. You want to know when the point 1, 0 would go back to here. So my first thought was, well, then it has to go 360 degrees, right? So when's the first time we'll see 360? Well, we'd see it at 719, right? Because, right? Because when's the first, well, so you always see the first time you ever see the number is at double the number minus 1, right? Like when the first time you see a 1 is at 2 minus 1. The first time you see a 2 is at 4 minus 1. The first time you'll see a 3 is at 6 minus 1. So you always end up seeing it at 2n minus 1. So I figured the answer must be 719. But here's the thing. If you're, remember, like this up arrow represents being from the left-hand side of the x-axis. So if you go 180 degrees from here, you're actually back to your starting point. So really, we need to know, when do we see 180? Well, let me draw that better. When do we see 180 in this direction? Well, we're going to see that at, so if we do this sequence 359 times, that's the first time we'll see it would have traveled 180 degrees from the point -1, 0. So therefore, it would be back to the point 1, 0. So this is a tricky problem just to understand it, but actually mathematically, it's not really that hard of a problem. It's just trying to understand what exactly it's asking you. All right, hope that helps. See you at number 16, or sorry, 19.